we're going to have to, when we do our next gas laws, which you all just correctly told me with Charles, is that it's temperature and volume. You have to change that temperature to Kelvin. And so what you're going to do, that's where the magic number 273 came from, is from the whole concept that all matter stops moving there. So let's take a peek at this PowerPoint starting from this slide then. It'll take me a sec here. I got to find my pen. And then we can move on here. So the next slide. Temperature is, again, usually measured with a thermometer in Celsius, but that relationship does not work with gases. All calculations involving gases should be made after converting the Celsius to the Kelvin temperature. Easy enough to do. Just add 273. Of course, you're going to solve for Kelvin then, and of course, I'm going to ask you in some problem to convert that back to Celsius. So that's what this second equation is saying here. Okay, missed my pen. Is that the second equation then is saying, here we go, that if I want you to convert back to Celsius, take that Kelvin and subtract the 273. Okay, so that's our first thought of today. You already told me what's the concept with Chuck. Charles' law is what two variables are you going to be using in your rectangles and boxes and everything else? Temperature and volume. And what kind of relationship is it? Direct. Boyle's is the only inverse. Okay? All the rest are going to be direct. Up, up, down, down. No matter which variable you put in. Okay? Did you get that data for the lab? Okay, I'll get it for you here. All right? So that's what Charles' law is going to be relating to. He measured the volume of air at different temperatures, and we already watched the video that's close enough to that. So Charles' law, remember, temperature has to be in Kelvin is what we want you to be doing. Okay, describes the direct relationship between temperature and volume. There you go. I'll put it here. I have to hold it. Okay. Has to be. Now, yesterday you told me, I hope on the lab, I hope you're telling me that it was P times V equals K, but today now, all the others are going to be V over T or whatever the other variables are going to give us some constant. So, when you're doing your problems here today, it's going to be, Charles' law, it's going to be V1 over T1 equals V2 over T2. Okay? That's what you're going to be looking for. Of course, we prefer the rectangles, so you're going to draw rectangles. That V goes down, therefore T goes down, and V goes up, therefore T goes up. And what if I give you temperature first? You'll put that in the rectangle first, and if it goes down, volume will go down. If your temp goes up, and again, make sure it's converted to Kelvin. Those temperatures are in Kelvin. The volume should go up. Okay? Charles' law then, here's just a nice little picture, Leonardo did it better, is that if I have V1 is 1 liter and T1 is 300 K, if V2 is 2 liters, meaning I increase my volume, that temperature should double. So I doubled my volume here, my temperature should double, okay, in order to get that. And again, V1 over T1 equals V2 over T2. And so you would get a constant when I divide V over T. That's what we're looking for here. Show me what this graph would look like. Connor, what does it look like? Which, just flat line? Like, oh, there we go. Good job. Okay? So that's what you need to recognize for Charles' law. As the temperature increases, volume increases. Okay? You're going to be asked to do all this on your homework, so you're keeping track of all this. Ready? Hello, go forward. Now, Gay-Lussac, there is a name. We are going to assign a name to the pressure temp. Leonardo said no, a little more research shows that Gay-Lussac can be attributed to finding out the direct relationship between temperature and pressure. So, temperature and pressure during his experiments, the volume, this is always something we do ask. Okay, and that is what's held constant. Okay, hopefully in Boyle's law, you said that the temperature and the number of moles were constant. In Gay-Lussac's, the volume and the amount, the N, the number of moles of gas were held constant. And it should make sense. You know, why do balloons burst when you heat them? Because they've got more pressure. When those molecules start banging around there, they're going to have more collisions, and that's going to increase the pressure. We used to do this lab. We used to have it where you actually increase the temperature, and you would see that the pressure on your pressure gauge would also go up. So don't forget, you've got to convert that temperature to Kelvin. You've got to add the 273. And the Gay-Lussac says that the pressure of a fixed mass of gas at constant volume varies directly with Kelvin temperature. Okay? And so what will that relationship look like? It'll be P1 over T1 equals P2 over T2. P over T equals a constant. Got it all? Ready to work a few problems or two? No, you got to correct something on this slide. We were trying to make the point, what will your rectangles look like? If T goes down, P will go down. If T goes up, P will go up. If P, all you got to do is switch these, okay? This one's P and T, and this one, we were just trying to show you that, you know, there could be any and all possibilities here for all these, okay? Goodness, you guys are naughty. Arrows move in the same direction should be what you should find on this particular. So tell me what this graph will look like. Connor's on the graph today. Connor's ready for the graph. He's right. Okay? It's a direct relationship, so it should all go up. I believe P over T then is going to be a constant. What happens again if my pressure is at 100 kilopascals? K is the kilo. You saw that on your lab quest yesterday. That's what pops up first. We changed to ATM so it was easier to see the relationship. 100 kPAs and 300 K. Well, what if I double my pressure? My temperature should double. Okay, so P1 T1 equals P2 over T2, and P over T will give us a constant. So that's all we need now, I believe, to get us, let's just do the summary slide. So you're asking what's on Thursday's quiz. We're going to give you a problem, one of each. Going to give you a Boyle's, a Chuck, and a Gay-Lussac. Thanks. Okay, so here we go, Boyle's. P up, V down, and all the other possibilities, right? You get the point that it's direct, indirect relationship. And this would be the mathematical equation. And what was held constant? Because you know I'm going to ask that. That shows up. Charles is direct as well as Gay-Lussac. So the only one that's different is Boyle's. If you just remember that Boyle's is different, you'll be in good shape. But both of these, as you increase one, the other will increase, and vice versa. It's going to be the V over V1 over T1 equals V2 over T2, and P1 over P2 is P2 over T2, or whatever variables I give you. P and N are held constant. There's no P in there. There's no pressure statement. And we haven't changed moles. And V and N are held constant. So this is what you're going to be asked on your quiz come Thursday. Okay, this is what will be on the quiz. The next one is combined, and we'll hold off on combined. So pull out 13.2, please. 13.2 is, there was a problem set. And maybe some of you stapled it to the PowerPoint. Perhaps you stapled it to that. But if not, okay, that would be okay by me too. Okay. So 13.2 and turn to page 3. Chuck. Yes. I didn't look at him. You're supposed to pass him in. Okay. So here we go. Charles. Where are we going to start? Where are we going to start here? Yep. Okay. Where are we going to start? That doesn't matter. Where are we going to start? Nope, we're trying to keep you guys accountable, right, Britt? You got to be accountable. Here we go. Emily, tell me for Charles' law, okay, what do you need? No, you're excused. I excuse all you guys. Emily, I would like to know what's all the variables and their relationship for Charles. What are we exploring here?
V1 over T1 times V2.
Okay, she's jumping to parts of these that we can certainly start here. Whoops, T1 and T2, right? Okay, that's one of the things. What else can you tell me about the rectangles then, Lily? If it looks like this, pick any variable. V, okay. So if V goes up, Lily, what will T do? Oh, okay. And if V goes down, T will down. And if T goes up, V will up, okay. And if T goes down, yeah, yes, Kyle. V will what? What will it do? Go down. Good job. Okay. Next, tell me what the graph looks like, Madison. You bet. Okay. Direct relationship is what we'd like to know. And tell me then, Aiden, if T1 is 200K and V1 is 1 liter and T2 is 400K, what will V2 be? Everybody's seen that? And what if I had T3 now, Nate, was 600K? What would, V3 be? Good. Everybody's helping him out. It should probably, why would it be 3 liters? And so if I'm increasing in those increments, yes. If I triple, it should be tripled too. Okay? Let's do our problem here. Let's do a problem, and so we'll work this all out. Carly, the temperature inside my refrigerator is 4 Celsius. If I place a balloon in my fridge that initially has a temp of 22, put a little degree sign there, it should have it, if it doesn't in that problem. Yeah, 4 degrees Celsius. Celsius always has a degree sign, Kelvin does not. 22 Celsius in a volume of a ½ liter. What will the volume of this balloon be when it's fully cooled by my refrigerator? So what is, step 1 is to do what in these problems, Carly? Okay, T1, T2, and V1 and V2. Good. Okay, what are they, please? T1? That would be awesome. Okay, you have to. Okay, so I will show you once. You certainly don't have to show me this work, but what Carly did is she added 273 right away. So 22 Celsius was initial, and she added 273, and she said it was what is it? Okay, first one. If it said it was initial, it's what? 295. 295K. And T2 is what? Okay, she took 4. And if it isn't 3 sig figs, please make it so here. Okay, so 3 sig figs is what we'll use every time. And that's where she got 277. You don't need to show me this work. You can just do 295, 277. Yes? Because look at how it read. Initially, the temperature was 22. I think I do that to you once on a quiz or test, too. Just a little heads up on that. It won't work. You'll get the wrong answer.
We have no more tests, right?
You have a quiz, you have 2 quizzes, and then the final. This is all going to be, this is what's on the quiz Thursday. Okay, what about my volumes then? Okay, hate to keep you awake there, Taylor, but what was V1?
0.5 liters.
Good. And again, make them 3 sig figs if we didn't. And V2?
We don't know yet.
Right. Okay. Well, our next step, my next step, and I don't need to be working in red here, Kira, is what? What variable do I have two pieces of information about? That should go in the rectangle first. So t did what? Therefore, v goes down. Good. All right. So now, step 3, Timmy, I'm supposed to do the mathematical. Okay, I'm supposed to do the mathematical relationship here. What is that? Oh, okay. You and I work the same way. I jump right to what is technically step 5. And he is saying, just get to work, Mrs. Reed. He says that V2 is going to be V1, right? Which is 0.500 liters times this conversion factor that's going to make my volume go down. So what is that conversion factor? It's going to go where? Okay. Well, this is what the system is supposed to help you with here, Timmy, is that go where the tip of the second arrow is pointing. The bigger number goes where the tip of the second arrow is pointing. 295K on the bottom, and what goes on the top? 277K. Okay, because we want 0.5 to go down, right? We want that volume to go down. So you would always multiply by a number that would give us something less than 1. For those of you that don't see it, do the math. Timmy skipped step 2 and 3. So back to you, Victoria. What's the mathematical relationship for this one? And so Timmy wanted to solve for V2, so that's going to be equal to what? Multiply both sides, right? Do your algebra. Okay, algebra. That'll cancel. So V2 will be equal to what? V1 times T2 over T1. So those of you that can't see this way, do it this way. Step 3, step 4. Okay, step 5 then is put your values in. And then step 6 is to solve, Carissa. 0.5 times 277 over 295 is what? 0.4. You got it. And now, folks, don't forget, I will grade that you cross out those Kelvin. They cancel. And so what's my label?
Liters.
Liters. Good. Okay, 3 sig figs. 3 sig figs. Alrighty? Questions?
Number 3, I know we have to show that stuff, but like, I don't understand your way of like
Doing algebra. Okay, you take, I want to isolate V2, right? That's my unknown. So how do I do that? I would multiply both sides by T2. And that would get rid of T2. It would be T2 V1 over T1.
Oh.
Or use your head. Point V2 times a conversion factor that's going to make that volume go down. Put the smaller number on top, bigger number on the bottom.
Do we have to show step 3
Nope.
in the quiz?
I never grade them. Okay? Never. Because this is what's important. That you know what you're trying to do here. You know what you're trying to do. Plus, this system works. It's almost foolproof. You check your answer. Did the volume go down? What did the arrow say to do? It better go down. Yes. You know you did something right when your box matches your answer. Let's do Gay-Lussac. Okay? Gay-Lussac is the next 2 problems here. Let's work. The first one says, what are the variables with Gay-Lussac? So, who are we up to? Kelsey. Yep. We're up to you now. Okay? So, Gay-Lussac, what variables again? Sure. And so rectangles would look like what, Connor, then? Good. And et cetera, right, team? You can draw the rest. Graph would look like what, Alyssa? Yep. Graph would look like that, summarizing all that. And what would give me a constant then, Phil? kind of skipped that on the last one. Is it P times T or P over T?
P over T.
Good. Good. Okay. P over T, and so, or T over P, or whatever. P1 over T1 equals K, P2 over T2. All right. Now let's do the problem. Okay, let's do the problem. So here we are, Alec. Step 1, reading the problem there. You got 54 kPa, temperature 35. Again, make that a degree Celsius. You heat it an additional 230 degrees. What will the new pressure be? So, what's step 1, Alec? You got it. And again, you don't have to change it unless I tell you to, but, and then, good, that's my unknown. I always stack them. You don't have to. They can be side by side, but I like to stack them because then I can see, oh, it goes up, it goes down. T. Okay, 35 degrees Celsius, and careful. Okay, we fooled some. We didn't fool everybody on that. It said it's 230 degrees, additional 230. Okay, 265. Everybody see that? That was the trick to this problem. But I can't use this in my problem, Alec. What do we have to do? I can't use Celsius. You got to change it to Kelvin. And how do I do that? 273. So what's the first one and what's the second one? What are those numbers in Kelvin? 308 and, okay, there we go. A rectangle for me, Lauren. Step 2 is a rectangle. So that's step 1. Step 2 is the rectangle. Put the variable that I have 2 pieces about in the box first. Bless you. What do we have? T up and what up? P up. Yep. There we go. Okay. Step 3, you're supposed to give me the mathematical formula here, Dallas. I don't know. No 35s. No 35. Mathematical formula. What's the relationship between P's and T's? Okay. What's the relationship? Is it P times T or P over T? So it's P1 over T1 equals what then, Dallas? Over T2. Step 4 says rearrange and isolate here. That what I want to solve for is P2. So if I solve for P2, what will that look like then, Amber? I've got to multiply both sides by P2, right? Say it louder, please. What? Times yep, that's why algebra, somehow everyday math kind of left some of us a little. Okay, look, I multiplied both sides by T2, so where does T2 go? On the top, and T1 on the bottom. Now, that's why I said I grade step 5, because can you use your head? P2 is going to be equal to whatever P1 was, 54 kPa, times a conversion factor of those temperatures that's going to make the pressure go up. So, Matt asks, which way should it look? And Travis, I want the answer when you're done.
538 over 308.
And don't forget the label, 538 over the 308. Once again, take a peek at, when you're stuck, take a peek at your algebra or take a peek at the rectangle. Put the bigger number where the tip of the arrow is pointing. Put it on top. Because 500 divided by 300 will be some number bigger than 1. It will make 54 go up. 54 times some number bigger than 1 will make it go up. So Travis, solving 54, that is a KPA, times 538 divided by 308. P2 is equal to what? I agree. 94.3 kPa. Don't forget, cross out those Kelvin. Cross out the Kelvin. You have two problems you have quite a few problems on the homework. Let's take a peek at 13.3 then. Take a peek at 13.3. And let me give you some answers. You start at 15 with the graph. Looks just like what we've been talking about. In 15, pick any points there, and you should get a constant. Let's jump right to giving you an answer for 20. Just write the answer down for 20. Step 6, way over to the side. V2 should be 0.667. For 21, you're solving for V1, should be 46.3 mils. Okay, and then 22 is 111. Okay, well, you're not done yet. You have to do Gay-Lussac's. So let me give you the answers then to 27 and 28. 27 is 3.27 ATMs, and 28 is 90.1 kPAs. So as you're doing your homework, please work as hard as you can to get those answers. Question? 3.27. Okay? Give yourselves, let's see your work for the next few minutes here. Okay? Okay. Let me just do this quick. Whoops. Refresh.